Hello students and welcome back to my channel. In this video we will be discussing questions which were asked on heat and simple harmonic motion. These questions were asked on the 29th of January 2024. I have combined the questions from both the shifts, that is morning as well as evening shift. Okay, and here I have collected maybe around 5 to 6 questions students from heat and dissection. And as you know, I have been teaching you shortcut techniques and also the exact method by which you are supposed to solve in the exam hall, so that you are able to solve the question within 1 minute, hardly 1 minute. Preferably, it should be less than 1 minute. In certain cases, it should not take more than 15 seconds to 30 seconds. Right, students? So, without wasting time, let us move to the next question, that is 21. A thermodynamic system is taken from an original state A to an intermediate state B by a linear process as shown in figure. This is the process, students, A to B, as you can see, A to B. Its volume is then reduced to the original volume from B to C by an isobaric process. This is the next process, students, B to C, you can see isobaric. So total work done by the gas from A to B and B to C will be. So as you can see, students, in order to know the what we call work done from A to B, from A you drop a perpendicular here, from A, and then from B you drop a perpendicular onto the volume axis. You get an area. This area will give you the work done by the gas, and as you can see, the gas is undergoing expansion, so overall work done will be, this work done will be positive. This area, positive area of the trapezium A, B, 0.7 and 3 and 8. So this trapezium. Then students, as you can see, that it undergoes a compression from B to C. So reach B and drop a perpendicular onto volume axis, then from C reach a drop a perpendicular onto the volume axis, you get a negative area. This area will be negative because the gas is undergoing compression. So that means overall area will be area of this triangle, and that will be positive, of course. Okay, students. So the required work done by the gas will be half into base. You can see base is 7 minus 3 meter cube. So 4 meter cube multiplied by height or altitude. Altitude is AC, which is equal to 8000 minus 4000. 4000 dyne per centimeter square. So 4000 dyne per centimeter square. So this will be 2 2s. So I have to convert this into dyne per centimeter square into Newton per meter square, so that everything will be in SI unit and you get the answer in joule. So this will be 4 into 10 power 3. The 1 dyne is 10 power 5 Newton and 1 centimeter is 10 power minus 2. Square will be 10 power minus 4. Okay, students. So you have 8 into 100, because this will be 10 power minus 5 upon 10 power minus 4. So this will be 10 power minus 1. So 110 gets cancelled. We are left with 10 power 2. So finally we have 800 joules. So we shall go with the option 1. Moving to the next question, question number 22. Two vessels A and B are of the same size and at the same temperature. A contains 1 gram of hydrogen and B contains 1 gram of oxygen. P and PB are the pressures of the gases in A and B respectively there. Now again, students, you can see, if you write from equation of state, so from equation of state we can write PV equal to nRT. In other words, pressure will be nRT by B. Okay. So as you can see, they are at the same temperature and they are of the same size. So that means for the two gases, temperature and volume is same. And R is anyway same because R is the universal gas constant. So we have pressure is proportional to number of moles. That's all. So therefore pressure of A to pressure of B will be equal to number of moles of A to number of moles of B. So here number of moles will be what? Mass by molar mass. So for hydrogen it will be 1 by 2. Whereas for oxygen it will be 1 by 32. So finally we have 16:1. So first option, we'll go with the first option. Then moving to the next question, 23rd. The temperature of a gas having this much molecules per cubic meter at this atmospheric pressure. So given K is Boltzmann constant, student. So we have to find the temperature. Now again we'll proceed with the equation of state. So equation of state states that PV equal to nRT. Now since we have been furnished the information regarding the number of molecules per cubic meter. So this N is basically number of moles. I can write this as total number of molecules upon Avogadro's number. Number of moles is equal to total number of molecules upon Avogadro's number. Also R by N is Boltzmann constant. Okay. Universal gas constant upon Avogadro's number is Boltzmann constant. So I have this. If I bring B below this, I will have pressure is equal to N by B, that is the number density of molecules. Okay students, number density of molecules. So therefore pressure is given as 1.38 atmosphere. You can take atmosphere as 10 to the power 5 Newton per meter square. Number density per unit volume is given as 2 into 10 to the power 25. Boltzmann constant is 1.38 into 10 power minus 23 into absolute temperature. Remember we will be getting temperature in Kelvin scale. So 1.38 gets cancelled both sides. Then we are left with what? See here. T will be equal to. So this will be 25 minus 23 is 2. So we are left with 1000 because 10 power 5 divided by 10 power 2 will be 10 power 3 and this 2 will go below this. So we have 500 Kelvin. So we will go with first option students. 500 Kelvin. Moving to question number 24. N moles of a polyatomic gas F equal to 6. F means degrees of freedom. Must be mixed with 2 moles of monatomic gas so that mixture behaves as a diatomic gas. The value of N is. So here we will be using this simple formula students. CV, that is molar heat capacity at constant volume for a mixture, is equal to N1 CV1 plus N2 CV2 upon N1 plus N2. Since the gas is supposed to behave as a diatomic gas mixture, so I will put this for the diatomic gas. For a diatomic gas it is Fr by 2. As you know, CV is Fr by 2. So for diatomic gas degrees of freedom will be 5. Okay, is equal to. Then for the first gas it is N moles. And for a polyatomic gas, it will be 6R by 2. For the second, you have 2 moles of gas and it's a monoatomic. So for monoatomic, you have 3R by 2. And divided by the total number of moles will be N plus 2. Okay students, so by solving this, you will get the value of N. Now you see students how to solve. Kindly see the technique I am adopting. In the exam hall, you are supposed to adopt the same technique. So first of all, think of cancellation. It's clearly, very clear that R by 2 can get cancelled. Is it students? Absolutely R by 2 gets cancelled here. And then we cross multiply this. So we have 5 into N plus 2. Whereas here we have 6 N plus 6. So upon opening the bracket, we have 5n plus 10 is equal to 6n plus 6. Therefore, n is equal to 4. It's clear cut. Okay students, moving on to the next question. Question 25. When the displacement of a simple harmonic oscillator is 1/3 of its amplitude, the ratio of total energy to kinetic energy is. So, you can see I'll draw a rough diagram so that you understand it. So understanding is very simple, very simple students. I will draw a straight line here like this. So this is the mean position, okay, and this is the amplitude. So the particle as right now suppose it is at a distance x, its displacement is x. Then we know total energy is half k a square. Whereas kinetic energy is half k into a square minus x square, where k is m omega square, where k is m omega square. A is the amplitude, x is the displacement. So since we have to find the ratio of total energy to kinetic energy, so we have to find E by K. So divide equation 1 by 2 to get A square upon A square minus x square. So this is the required ratio. So it is given that x displacement is 1/3 of its amplitude. So we have been given that x is equal to A by 3. Students, kindly don't confuse that x with this x. Okay, this is different. Alright. So when we substitute here, we get the required ratio as a square upon a square minus a square by 9. So it is 1 by 1 by 9. You can cancel a square. So 1 minus 1 by 9 is 8 by 9. So 9 goes up, you have 9 by 8. So x, that is the numerator is 9. We'll move to the next question, students. Question 26, as you can see, a simple harmonic oscillator has an amplitude A and time period 6 seconds. Time period is given. Assuming oscillation starts from its main position, the time required by it to travel from x equal to A to x equal to A root 3 by 2 will be pi by x seconds, where x is. Now this question can be comfortably solved if we use the concept of reference particle and reference circle. We can comfortably solve this by using reference particle and reference circle. So this is a reference circle, students. I take this diameter. I'm sorry, this is so this is a diameter. This is the midpoint, that is the mean position, and when the particle is at the mean position, m, that is m is undergoing SHM and p is the reference particle, it rotates in the anti-clockwise sense with an angular speed equal to omega, constant angular speed, where omega is the angular frequency of the SHM. Now let us say that it was initially at x equal to a, so m was here, m naught. So P was also there, students, T equal to 0. Now it comes to a displacement A root 3 by 2. That means M is now here and P naught is, P is here. It travels from this point to this point. So meanwhile, as you can see, students, that the radius vector is rotated by this angle. Since the radius is A, and this angle is this, you can clearly see that cos theta is equal to cos theta is equal to base upon hypotenuse. So very clear, you can see theta is 30 degrees. So it has to rotate by 30 degrees. This radius vector has to rotate by 30 degrees. And as you know, in order to rotate completely by 360 degrees, the time required is period of oscillation, which is 6 seconds. So therefore, in order to rotate by 30 degree, we can simply apply the unitary method, because after all, the reference particle is undergoing uniform circular motion. So that means, very simple, students. In order to rotate by 360 degree, the reference particle, it will take how much time? 6 seconds. So in order to rotate just 30 degrees, the time required will be 6 pi into 30 by 360. So 30 by 360 is 12, so 6 pi by 12 is pi by 2. So x is 2 seconds. I hope that is clear, students. Right, moving on to the next question. That's all, students. That's all in this video. Thank you so much for watching my channel. Please do subscribe and hit the like button. Thank you so much.